everyone, in this video we are going to look at logistic functions. So you already watched a video that was an example of a logistic function. It was like an intro. Here I'm going to give you some notes on logistic functions and then do an example with you, a word problem example. Alright, so logistic functions are functions of the form y equals c over 1 plus a times e to the negative rx. Okay, some of these letters might be different in different resources that we use, but where they are in the equation and what they mean will stay the same. So what I mean is, like in the video that you just watched, this c here was called L. So different people call them different things. For your notes, these are the letters that I'm using. Okay, in this example, and any logistic function, a, c, and r are all positive constants. Okay. Why we have logistic functions is to model growth that levels off. Okay, so I'll write that down for you. It's used to model real life quantities whose growth levels off because the rate of growth changes. So it changes from increasing growth rate to decreasing growth rate. It's still growing, it's just not growing in an increasing rate at the end. Okay, some common examples would be like a bacteria culture or a population model, where there's only a certain amount of space that you could include the people or include the bacteria, like a petri dish or something. So there is what we call a capacity, a maximum, and that's what that L or C is. All right, so a couple more notes on the next slide about the. All right, so first thing you should know is that we have two asymptotes, two horizontal asymptotes. So the horizontal lines of y equals 0 and y equals c are asymptotes. Okay, so that same c that you saw on that first slide. Okay, the y-intercept, that's just always when x equals 0, right? We already know that from any other function. So in our case, that's going to be c over 1 plus a, because what happens in our model is that we would have c over 1 plus a times e to the negative r times 0, which would result in e to the 0, which is just 1. So you're just left with c over 1 plus a. The domain of the logistic function itself is all reals, and the range is going to be 0 is less than y, which is less than c. So you're going to be in between those two asymptotes for the range. In terms of the graph itself, it's going to be increasing from left to right. Again, we'll look at an example. And then there's a very important point on the graph, which is called the point of maximum growth. All right, I'm going to show you what this point is, but I'm also going to tell you how to find the point. So that's going to be in this last note, and things about the point. So to the left of the point of maximum growth, which is the natural log of a divided by r, that's the x value, comma c over 2, which would be the y value. The rate of increase is increasing. Okay. To the right of the point of maximum growth, I'm just going to write to the right of the point, the rate of increase is decreasing. Okay. So now I'm going to actually show you example and show you where all these things are on the graph. All right. So here's an example. It's about the number of students infected with the flu after T days at some Springfield High School, and we have this function here which correlates to the graph here. So we're going to look at the graph for just a minute before we even look at the questions. All right, one are horizontal asymptotes. So I know that the capacity is 1600, so 1600 on the graph, and even when you look at it, it kind of looks like it levels off here. That's the first asymptote. And then when you look at the bottom of the graph, this is the other asymptote. So remember I said the asymptotes are y equals c and y equals 0. So here it's y equals 1600 because that's c in the equation, and y equals 0. Okay, the y-intercept is somewhere down here. We could find it by plugging in 0 for t in this case because we have t there. And we will do that in letter A. Okay. The other thing is the point of maximum growth. All right, the point of maximum growth is always going to be halfway in between the two asymptotes. Remember that I said the y-coordinate is c divided by 2. So in that case, it's going to be c, or 1600, divided by 2, or 800. So it's going to happen here at 800. So right here. Now I just want to explain what that last line meant. Okay, so since this is the point of maximum growth here, I said to the left of the point of maximum growth, the rate of increase is increasing. So as we go up here, the rate that we're increasing by is growing. It's fast, it's increasing. But to the right, I said to the right of this point, the rate of increase is decreasing. So we're still increasing, but at a decreasing rate. So it does level off here. It gets slower the way that we're increasing. That's what that line meant. All right, and now I'm going to show you how to answer some of these questions here. These are typical questions that we could ask with logistic functions. All right, so the first one, what is the initial number of infected students? So we would plug in t equals 0. I'm going to do the work down here. So I'll have p of 0 equals 1600 divided by 1 plus 99 e to the negative 0.4 times 0. Okay, I already kind of told you how to find this. It's really just c over 1 plus a, but I'm going to do the work here anyway. So it's 1600 over 1 plus 99 times e to the 0, which is 1600 over 1 plus 99, which is 1600 over 100, which is 16. So what was the initial number of infected students? 16 students. Okay, I'm going to go to the next slide to answer B. All right, after 5 days, how many students will be infected? Because I just don't have room here. All right, so we already answered A, now we're answering B. So after 5 days, that means we're plugging in 5 for T. Okay, so now we have this. And we just need to solve it. So we're going to use our calculators for this. And I see that e to the negative 0.4 times 5 is somewhere decimal. So I'm going to have 1600 over 1 plus 99 times 0.135. Okay, and that's the same as 1600 over 1 plus 13.39, which means I have 1600 over 14.39, and then I divide the 2, and I get 111.125. So I'm going to write that out here, which is really 111 students. Notice I wrote approximately. All right, what is the maximum number of students that will be infected? Well, that's our capacity. That's the maximum number that could be infected. So again, that is that 1600 number. So 1600 students. All right, the last question I'm going to do, remember I did this here. This is just the capacity. The last one I'm going to do on the next slide. All right, according to the model, when will the number of students infected be 800? So that means I'm plugging in 800 as the output. So now I have to solve this equation. All right, I do want this out of the denominator, right? Because I have the variable in the denominator, so I'm going to multiply both sides by the denominator. Okay, and I'm going to have 800 times 1 plus 99 times e to the negative 0.4t equals 1600. I'll divide by the 800. So now I have 1 plus 99 e to the negative 0.4t equals 2. Okay, and now I'm just going to go over here to continue to show my work here. Subtract 1 on both sides, and I have 99 e to the negative 0.4t equals 2. Sorry, that's 1. I subtracted 1 and I didn't write it. Okay, right, so I subtracted 1 from both sides and I didn't write it. That's 1. Now I'm going to divide by 99. So I have e to the negative 0.4t equals 1 over 99. Because this equation has e as the base, I'm going to take the natural log of both sides. So now I have negative 0.4t equals the natural log of 1 over 99. Divide both sides by negative 0.4. And now I'm going to use my calculator. So I have the natural log of 1 divided by 99 divided by negative 0.4. That is 11.487. Okay, so here I'm going to write in 11.487 days. Okay, and I'll just leave it like that. Now, one thing that we didn't do, I thought might come up in the questions, was find the point of maximum growth. We found the y-coordinate when I was just showing you the actual graph, like I was just describing the graph, but I'm gonna now find the point of maximum growth with you so you know how to do it. So this is the last thing, finding the point of maximum growth. All right, remember that we already said it's this point here, and it's important if I ask you to sketch the graph because you would get the asymptotes, the y-intercept, and the point of maximum growth. All right, so it's going to be the natural log of a over r, comma, c over 2. We already found the c over 2, that's 800. So now I have to find the natural log of a and divide it by r. So that's just by looking at the equation. Remember that the equation, the general form is y equals c over 1 plus a times e to the negative rx. So the natural log of a in this case is 99, so it's going to be natural log of 99 over 0.4, which means I have natural log of 99 divided by 0.4. So you're going to notice we actually get the same answer that we got for the last one, right? So I got here 11.487, which is what we got before for letter D, but I went about this a different way because I was just asking to find the point of max growth, and it just so happens that it corresponds, right, because I asked about 800. But I wanted you to know how to find the point of max growth without like just plugging in what the y value is, because you could find it with this equation instead if I just ask you what's the point of max growth. So you just actually find that. It's just a coincidence that that last problem had 800 as the y. Okay, and that's how you would do it. So this is the point of maximum growth if I asked for it. All right, so some things that I could ask you for logistics are questions like this. So a word problem where I ask you questions about it, you use the equation or the graph to figure out the answers. Or like sketching a graph, and to sketch a graph you would just use the asymptotes and the y-intercept and the point of maximum growth and literally just like sketch it out like this with those things. And that is pretty much it, other than maybe writing the equation from some information. But yeah, that's what we're doing with logistic functions. So thank you for watching, and now you should be able to complete the logistic function example worksheet.